All right, in this video we're going to go over the last question from your in-class or, sorry, on Schoology practice AP exam. I skipped the one about drawing the slope field one. I appreciate everybody's sort of ingenuity in getting past the technical hiccup there. But two, it looked like everybody had good success on that one, so I'm not doing a video for that. So we need to know if we have a relative maximum, relative minimum, or neither at the point 2, 3. The first thing that has to be true to have a relative maximum or minimum is that the derivative has to be either 0 or undefined at that point. So that's the first thing we need to check here in part A. What is dy dx given the point 2, 3? Well, that's going to be 2 times 3 minus 2 times 3, which is 0. So that doesn't actually answer the question by itself. I had a couple people say, oh, the derivative is 0, so it's got a maximum. Well, how do you know it's a maximum and not a minimum? So we have to have some other way to know that it's a maximum and not a minimum. What a few people tried to do was try to plug in points. But the issue that arises there is you have to plug in both x's and y's. And so there's sort of like you've got the point 2, 3 here. You need to think about what happens when the x is less than that point, but the y is more than that. What happens when the x is less than that point, and so is the y? What happens when both x and y are more than that point? What happens when x is more but y is less? And then how do you know which direction the function is going there? So we're not quite sure whether the function, we have to kind of consider which of these is happening, and we don't actually know. So plugging in points when you have both x's and y's as part of the derivative is not the ideal way to do that. Much better to consider the second derivative instead. So instead of the plugging in, we consider the second derivative here. And so we then actually have to take the second derivative. So the second derivative, I need product rule, so let's leave the x, take the derivative of the y, plus take the derivative of x, leave the y, then minus, well, no product rule here, just 2 dy dx. Now, sometimes when we do a problem like this, we actually need to take the equation for dy dx and plug it in here where we see the dy dx's in our second derivative. But in this case, it's much easier to just plug in the known value of dy dx at that point. That's often easier, but in this case it's especially easier because we know that at the point we're interested in, 2, 3, dy dx is actually 0. So this is going to be 0, this is going to be 0, and all we have is plus 1 times y, which is 3. So dy dx is going to be positive, which means that we're concave up. Now if my first derivative is 0, we have a horizontal tangent line, and we're concave up at that point, we have to have a minimum. And then make sure that you actually justify that. Make sure that you actually say it's a minimum because the first derivative is 0 and the second derivative is positive. That's all you have to say. You don't have to explain why that's true, but you have to say something to justify. A couple people lost points because they just, they didn't justify. And maybe we were just guessing and we got lucky, but for some people we actually showed some good work but then just didn't justify. Work is not justifying. Words justify. Okay. Part B, list the coordinates of any points where we'd have a vertical tangent line. Well, in order to have a vertical tangent line, the derivative needs to be undefined. There's no values of x or y that this is going to be undefined at. So we would just say, because it says or explain that no such points exist, We say no such points exist because no values of x and y are going to make that derivative undefined. Part C, we need the tangent line, so that's going to be y minus 3 is equal to our slope times x minus 2. But our slope is 0. We already know that. So that means the whole right-hand side goes away, and we're just talking about y equals 3, which means no matter what I plug in, I'm going to get y equals 3 out. So we would say f of 2.1 is approximately 3. Okay. So then for part D, we actually have to solve. Find an equation for f of x in terms of x. That's the same as saying just, okay, solve this differential equation. Let's clear out some room because we're going to need some here. Hopefully we know by now that we can only solve differential equations by separating the variables. So I like to look at this one, in fact, by factoring out a y first. And you don't need to show that step, of course. If you're just like, oh, I can divide a y to the other side, that's easy. Great, but I like to show that step. It just helps my brain see what's happening. So then we get 1 over y dy is equal to x minus 2 dx when we separate. Take the antiderivative of both sides. Natural log of absolute value of y is equal to 1/2 x squared minus 2x plus c. Don't forget your plus c. So crucial that we remember that plus c on the AP exam. And here's why. At this point, we've basically done two things in this problem. If you leave off the plus c, you can't get anything after that correct. There's probably going to be 2, maybe even 3 points available from here. This part D is often worth 5 points. 1, separating. 2, anti-differentiating. If you leave off the plus c, you might get this second point. But anything after here is all about the c, and so you won't get any of those points. So remember your plus c. Okay. So we can solve for y first and then solve for c, or we can solve for c and then solve for y. I like to solve for c first. So this is natural log of 3. Hey, where'd the absolute value go? Well, the absolute value of 3 is 3. Plug in 2. So then the 1/2 2 squared, well, that's just 2, and then minus 4, so that gives me negative 2 on the right. Add that to the left side, and we get 2 plus ln of 3 is equal to c. So sort of an uglier c value here, but that's all right. I'm going to go ahead and change color. So now that I have that c value, we're now going to say the natural log of y is equal to 1/2 x squared minus 2x. Let's get a little more room. And then plus 2 plus ln of 3. Just taking that c value that we just found and plugging it in over on the plugging it in for c, keeping everything else the same. Okay, so now solve for y. We just take take e as the base on both sides. So this just becomes y. Actually, forgot my absolute value there. So this just becomes the absolute value of y equals e to all of this ugliness. Now we can definitely simplify this a little bit, and I think almost everybody tried to simplify this. On last week's quiz, when it was multiple choice, you had to simplify because the choices all involved simplifying. But on a free response, you don't have to simplify. Now there is something I still have to do, but I don't have to actually simplify the right-hand side. A lot of people made a mistake. We took this ugly C value and we approximated it as like 3 point something. And then we tried to make that the coefficient. Well, that's not how that works. So just leave it like this. If I wanted to, you could break it up as e to this power times e to this power times e to this power times e to this power. And it's only this last one where the e and the ln cancel out. So you could have a 3 as a coefficient, but this 2 wouldn't be a part of it. Okay, but I do have to figure out, do I want the positive or the negative version of this? And the way that we figure that out again is if I plug in 2 for x, I need to get a positive 3 out. So if I plug in 2 for x, this is going to be 2 squared is 4, half of that is 2. Minus 2 times 2 is negative 4 plus a positive 2. That's all 0. So I just get e to the ln of 3. E and the ln cancel out, leaving me with 3. Now, I don't need the plus and minus because I want this to be a positive 3. So I'm just going to say y equals e to the 1/2 x squared minus 2x plus 2 plus ln of 3. Because technically, instead of writing absolute value of y here equals this, I can just get rid of the absolute value and put a plus and minus on the other side. But then I have to pick, is it the plus or is it the minus that I want? And it's the plus, because that's the one that will give me positive 3 out when I put in a negative, or when I put in a positive 2. Okay.